Okay, section 10.2 deals with this concept of tangents to a circle. So up top, they have the theorem for tangents to a circle. So it tells us if AB, okay, so if our line AB is tangent to circle C at point P, then AB is perpendicular to CP. So really what they're getting at here is that if we have a tangent to a circle, it's going to make a 90-degree angle with the radius at the point it touches the circle. And that's going to come into play for this first example we're going to look at. So example 2, they want to know, is KJ, okay, so we have this segment right here, is KJ tangent to circle P at J? So the way we're going to go about looking at this is we're going to use the Pythagorean theorem. Okay. Remember, Pythagorean theorem is c squared equals a squared plus b squared. And the key to this whole problem is figuring out what c is. So if KJ happens to be tangent to the circle, our hypotenuse would be this side over here. Okay, so this 4 and 6 would be our c value. Now, when we plug it in, we need to realize that 4 and 6 combine to give us 10. So we plug it in, we end up with 10 squared on our left-hand side. Other side, we'd have 6 squared plus 9 squared. So working through that, 10 squared is 100. 6 squared is 36. 9 squared is going to give me 81. We go ahead and work it out. You get 100 equals, what's that going to be, 117. 100 does not equal 117. So since they are not equal, we would say KJ is not tangent to circle P at J. If it worked out where the two of them were equal, so I got 100 equaling 100, then we could go ahead and say, hey, it's tangent. But since they're not equal, KJ is not tangent. Okay, we're going to skip B. Next one we're going to look at is C. So on this one, they go ahead and tell you that line M is tangent at B and line N is tangent at C. So as soon as we see that we have tangent lines going on here, we can go ahead and throw 90s in here. So I got a 90, got a 90. And they are asking us what is the value of X. So I look at this right here. I got 1, 2, 3, 4 angles for that polygon. And when you have 4 angles from first semester, you should know that those all add up to 360 degrees. So I know that my X plus 90 plus 135 plus 90 is going to equal 360 degrees. So to go ahead and solve this, you need to use your Algebra 1 skills. So on this left-hand side, if I go ahead and add 90, 90, and 135, it's going to leave me with 315. So I have X plus 315 equals 360. And then solving for X, we go ahead and subtract 315 from each side. And doing that, I'm going to be left with X equaling 45 degrees. Done. Okay, last one we're going to look at, and like I said, we're only going over the basics of tangents today, is the example 3. Try it. So when you have lines that are tangent, so in this case we have XZ is tangent and YZ are tangent. Obviously my radiuses, or my radii, are going to be congruent. And then what also happens here is that my two tangent lines are congruent. Okay, so we can go ahead and start like filling information in. So they tell us that TX is 12 and TZ is 20. We can go ahead and find the missing information. So they want to know what XZ is. So XZ equals what? If it makes you feel better, we can go ahead and redraw xz so that we just have a right triangle going on. So I go ahead and redraw that. We got our 20. We got our 12. And we should have a 90-degree angle here, trying to solve for xz. Okay, so there's my setup. Again, right triangle, we go back to first semester and the start of this semester, it's Pythagorean theorem. So c squared equals a squared plus b squared. My c is going to be the 20. So we have 20 squared equals 12 squared plus xz squared. And then we use our skills. So 20 squared is going to give me 400. 12 squared is going to give me 144. And then to solve for xz, you subtract the 144 over to give us 256. And then I don't want xz squared, I just want xz. So go ahead, square root each side. So I'm going to square root the 256. We're going to be left with xz. Let's see if I can save that. Xz equaling 16. And then, since I said that both of those are going to be congruent, not only does xz equal 16, but yz as well is going to equal 16. Okay, so those are the 3 examples from the notes. I want to look at a couple from the worksheet that you're going to have today. So let's look at number 4 real quick. Number 4, they want you to go ahead and solve for the question mark there. Okay, on this worksheet, they go ahead and tell you that all the lines which appear to be tangent are tangent. So that means for number 4 that I have a right angle right here. Okay, so my first step in solving for the question mark would be to figure out, okay, what is this full side right here? So what does c equal? Leaving us with c squared equals 12 squared plus 16 squared. You go ahead and work it out. So 12 squared plus 16 squared is going to be 400. Leaving us with c equaling 20. Now, the question mark is only this section right here. Okay, so if this full length is 20, we need to figure out what the question mark is. Well, our radius is going to be 12 all the way around. So from here to here has to be 12. So for the question mark, we're thinking, okay, 12 plus what is going to give you the 20? And it just so happens in this problem it would be 8. So 12 plus 8 gets me to 20. There's my question mark. We're all good. Okay, last one I'm going to look at is on the back. On the back, they want you to solve for x. Again, they say assume all lines that are tangent or appear to be tangent are tangent. So in this setup, okay, since these are both tangent, I know that these two are congruent, and then these two are congruent as well. So since those are congruent, you can go ahead and set the expressions equal to each other and solve. So you get your x's to one side by subtracting over, get your numbers to the other side by adding, and we are left with x equaling 12.